This video is about in behavior, and now that we know about even and odd degree polynomials, we can identify in behavior just by looking at the equations. So let's review. We know that an even degree is going to have in behavior going in the same direction, and if it has a leading coefficient that is positive, it's going to look something like that. The in behavior is. Oops. And that same even degree polynomial, if the leading coefficient is negative, that's going to flip it. Okay, the polynomial shape, the key being that in behavior is in the same direction. Now, if our polynomial is an odd degree polynomial and it has a positive leading coefficient, it's going to have what we're calling a cubic curve shape, or specifically the end behavior is going to be going in opposite directions. Now, when the leading coefficient is positive, the right side is going up. When we have an odd degree polynomial and the leading coefficient is negative, it reflects over the x-axis, just like we know all transformations do, and it's still a cubic curve. The in behavior is still going in opposite directions, but now the left or the right side is going down. Okay, so that's something that we just have to kind of memorize and ingrain in our heads. Now we are going to look at an easier way of writing our notation, because first semester we were kind of helping you with it. This semester you need to know it. So if I've got a graph that looks all crazy and I want to write my in behavior, well, let's look at the right side of the equation. This end of the equation, or the graph, is in the first quadrant. Now look at what I've done here. I have labeled, instead of just labeling x, y for my grid, my axes, I'm actually saying x approaches infinity on the right end and x approaches negative infinity on the left. On the y-axis, y approaches positive infinity up top and y approaches negative infinity on bottom. What this allows me to do is when I go to write my in behavior, I'm just going to look at what quadrant I'm in. Now remember, we're always going to start with the x, so as x approaches, well, in this quadrant it approaches positive infinity, y approaches, here it approaches positive infinity. Then I go to my left side, and in this quadrant it tells me that as x approaches negative infinity, y is approaching negative infinity. And now we've got a nice easy way of doing our in behavior. Okay, so let's look at another graph. Here we have a graph that, by looking at the in behavior, I know that it's got to be an even degreed polynomial, because my in behavior is going in the same direction on both ends. And since it's going down, I know that the leading coefficient has to have a sign that is negative. Alright, so with that said, let's go ahead and do the right side. It is in the fourth quadrant, where as x approaches positive infinity, y approaches negative infinity. And then I look at my left side. It is in the third quadrant, so here as x approaches negative infinity, y is approaching negative infinity. So hopefully this will help you out a little bit as you start having to write the notation on your own. Alright, let's look at an equation example. So remember, the things, when we're given an equation, we have to look at the degree, And what is my degree for this equation? It is a 3, which is an odd number. So that tells me that my end behavior is going to be going in opposite directions. And then the sign of my leading coefficient, and I am going to abbreviate leading coefficients LC. My leading coefficient is -2, so the sign is negative, which means the right side is going to be going down. It's going to look like that. So when we graph this, let's see, our y-intercept is going to be -1, so we can at least do that correctly, or specifically. So my right side, as x approaches positive infinity, y approaches negative infinity. And my left side, as x approaches negative infinity, y is approaching positive infinity. Okay, pause if you need to get your head wrapped around that. I may have done that a little quickly. When you're finished, hit play again, and let's do another example. Here is an equation. This one is in factored form, so we might have to do a little bit of work. So my degree, I've got to calculate. So I have got an x times an x is x squared, times another x is x cubed, times another x is x to the 4th. That is an even number, an even degree. The sign, let's see, what does that even tell me? It's even, so my end behavior is going to be going in the same directions on both ends. The sign of my leading coefficient, again, I'm going to abbreviate leading coefficient LC, means I've got to take this 1x times this 1x is 1, times that 1x is 1, times that 1x is 1. So my leading coefficient is a 1, and it's a positive. So that tells me that both ends are going to be going up. Now let's go ahead and look. We've got a -3, 0. We have a -1, 0. We have a +2, 0. And we have a +4, 0. Now remember, I know that my end behavior is going to be going up on both ends. So I come down, and I have to cross the x-axis each time because my multiplicity of each one of those has an exponent of 1. Alright, just trying to pull everything that we've done so far into this example. So this right side is in the first quadrant, so as x approaches infinity, y is approaching positive infinity. Okay. And as x approaches negative infinity, y is again approaching positive infinity. So that is our end behavior. Pause, look through it, make sure you understand where each thing's coming from, rewind if you need to. That's how we can tell end behavior and make it easier to write by putting these on our axes when we get started.